Good morning, honors geometry students. I want to introduce you to section 3 of chapter 12. It deals with pyramids and cones. Mr. Robitaille introduced you to lateral area and surface area of prisms. I want to briefly show you the difference, and hopefully that will help you understand some of the things. These two shapes that are right before you are a combination of a pyramid and a cylinder, or not cylinder, and a prism. This is a cone and a cylinder. So you can see, hopefully, the difference between a pyramid and a prism. And it is really important as you move forward through this chapter. And if we were to have a test, then you need to carefully know, am I dealing with a cone or a cylinder, or am I dealing with a prism or a pyramid? Now, the reality is pyramids and cones are really the same or similar. It's just what the bottom is. And so just understand, and I will reiterate, I'm sure, something that Mr. Robitaille talked about, and that is, in a prism, you have two bases that are the same, and they are parallel to each other. So don't forget that. And then you have, again, a prism that has octagons for two bases. And so remember, it doesn't matter whether it's oriented horizontally or vertically, it's still a prism. It doesn't matter which way you look at that. But remember that your formulas for that, for the surface area of either one of those shapes, is the perimeter of the base times the height, which is the distance from base to base, plus two base areas, because there are two bases. And so you're going to have to use chapter 11 to find the area of bases in this chapter. So hopefully you learned what you needed to learn last chapter. Now, with pyramids and cones, the formula is a little bit different. For one thing, we only have one base. So when we do surface area, we're only going to add one base area to it, and that's a place where students make mistakes. So be careful about that. The other thing is, it's not just the perimeter of the base times the height. It's 1/2 the perimeter of the base times what's called the slant height. And so what is the slant height? Well, here is a stick figure of a pyramid. It's a square pyramid, would be considered a regular pyramid. The red stick in the middle, that would be the height of the pyramid. Now, I'm going to show you where the slant height would go. The slant height would go right there on one of the faces of the pyramid. So I'll try to hold that. You can see how it covers that up. It's directly in that. It is the height of the face of this triangle. That's the slant height. And the slant height is important because if we're going to find the surface area of this, we have to find the area of the base and then find the area of the four faces. Now, with a regular pyramid, that means all of these are the same. All of these triangles would be the same. And so you could find the area of the triangle and then multiply by 4 and you'd have it. And a lot of people prefer to do that. That's called folding it out and having a net and calculating all the area of that. But there's a formula for this. They show all of these formulas together for prisms, cylinders, pyramids, and cones. I personally don't like to remember, per se, or memorize the cylinder and the cone, because all I'm doing is applying the circumference for perimeter and applying area for the area of the base. So I don't like to separate them. I just like to remember, okay, the lateral area of a prism is the perimeter of the base times the height, or the surface area is perimeter of the base times the height plus two base areas. So the same thing is true about pyramids. You can just simply know these two formulas, and it will allow you, as long as you remember circumference and the area of a circle, you can just simply apply those appropriately there. You're gonna have to do that with other figures anyways. For example, here's an octagonal pyramid. To find the area of this, you have to remember 1/2 the apothem times the perimeter. So, you know, here's not a regular pyramid. This is now a rectangular pyramid. And as a result, the slant height here and the slant height here are not the same. So I'm going to have to find the area of those two triangles, the area of these two triangles, and then add the rectangle. So you'd have to do this in parts. You could not use the formula. These formulas are only for regular pyramids. And so be careful about that. Now, again, how can I show you where the slant height is? Well, in a cone, it's simply this height. Now, keep in mind that in a cone, that height is the same all the way around. It doesn't matter where you draw that, where it goes. So cones are very easy to work with because there's not a lot of different lengths involved. Now, let me go back to this pyramid again. Now, remember, this is the height. That's the one in the middle. This edge here is called the lateral edge. And then, okay, there's my slant height. My slant height goes here. So you have to make sure you're careful about reading and noticing, do they say slant height? Do they say lateral edge? Do they say height? So there are 3 different lengths that seem to be fairly close, but you have to be very careful about distinguishing which one they're giving you. So be careful about that. The other nice thing about pyramids, well, some people might think it's nice, you have a right triangle. And in fact, you have 3 different right triangles. You have one here in the face of that triangle. You have one here with the height and what we would call the apothem here and the slant height. And then we have one where we have the height, half of the diagonal, and then the lateral edge. So be careful because a lot of these different problems will make it a little bit tricky about finding the slant height, finding the height, but you're always going to be using Pythagorean theorem. So be aware of that and understand that, know that difference. So I'm simply going to now proceed to do some examples for you using these formulas. And so I'm going to write them and you're going to see them. So here's the first one. This is just the first example in the book. You start the homework at number 7. This is number 1. So if these problems ask for the lateral area and the surface area. Now what you need to know and remember about the lateral area formula, it is, or for the surface area, it is 1/2 the perimeter of the base times the slant height. Now those are the symbols that we use, plus 1 base area. Now the lateral area is simply 1/2 the perimeter of the base times the slant height. Now notice the lateral area is a part of the surface area formula. So if you simply remember that this portion of the surface area formula is the lateral area, you really only have one formula to remember. It's the same thing that you talk about with the prisms. The surface area is the perimeter of the base times the height. That's the lateral area. And then you add 2 base areas. So in reality, in this chapter, we only have 2 formulas to remember if you really want to narrow it down to exactly what you need. Now, do you need stuff from our previous chapters? Absolutely. And we'll see that right now. So this is a regular pyramid. It's given us the side of the base, and it's a square base. So 16 times 4 would be my perimeter times 1/2. And then my slant height is given to me as 12. So this is a very basic, simple problem. And so you would need to multiply those out. Let me see if I can do it in my head quickly here. 32 times 12, 320, 384. So that would be the lateral area. Now, do I need to recalculate it? I don't know. I'm just going to go 384 here, and then I'm going to add to it one of the base areas. Now, it's a square on the bottom. So a squared is nothing more than the side squared. So 16 squared, that's 256. So when I add those together, I'm going to get 640. And there's my surface area. Make sure that you distinguish between those two when they ask for that. So there's the first, and that's a very basic example. That's probably as easy as it can be. So there's that problem. Now I'm going to go on to the next problem. Okay, now we get to another pyramid. Now this is a little trickier because it is now has a regular pentagon as a base. So again, I need the lateral area and surface area. So I'm just going to write down the surface area formula because I know this part is the lateral area. Well, all I need is the perimeter of the base and the slant height. Well, this gives me the slant height. If you look at that picture, the dotted line is on the face of the triangle. It is not the height of the pyramid. So I'm simply going to go 1/2. Well, if it's 5 sides and 7 is one of the lengths, 5 times 7 for 35 times, and then 9 for the slant height. So let's see. 9 times 35, that would be 45. Put the 4 up. 7 plus 4, 315. And then take half. So that would be equal to 157.5. And that would be the lateral area. That would be the first answer. Now I need to add to it the base area of that pentagon. Now, we go back to last chapter, which many of you showed me that you had difficulty doing that, or doing this. This, remember, you divide up, and we'll be reviewing this all the time. One of these angles is 360 divided by 5. That would be 72. So if I drop this down, I make that 3.5, and that angle is 36. Now I need this apothem. So my area for my base is 1/2 the apothem times the perimeter. Well, I know my perimeter is 35. So now all I need to do is find my apothem. So sorry if I made that look like a 9, but it's an A. So this is opposite and adjacent. So that means tangent of 36 is going to be equal to 3.5 over the apothem. And so the apothem is equal to 3.5 divided by the tangent of 36. So I'm going to put that in over here, 3.5 divided by the tangent of 36. Now, I do have my calculator, so I'm going to do that work first. 1/2 of 35.7, or of 35 is 17.5. And then I'm going to multiply that times 3.5. And then I need to divide by the tangent of 36. And I'm going to get 84.3. So this is 84.3. When I add, that's just for the base area. When I add to that 157.5, I get 241.8. Now let's make sure Mr. Brower has done his work correctly. And check that answer. Yes, those are correct. And that's with the pentagon. That's going to be some of your more challenging problems. You really have to work at breaking it down into two separate problems for the lateral area and then the base area, working on things that you learned in last chapter. All right, let's go to another example. And this one now deals with a hexagonal pyramid. So in this problem, they've given us the height and they've given us the slant height. It's not super easy to see that, it's kind of blurry, but it's number 3 in the book on page 859. So you can kind of look along with that if you want. So again, our formula for the surface area of a pyramid is going to be 1/2 the perimeter of the base times the slant height plus 1 base area. So can I find the perimeter? No, I can't at this point because they haven't given me a side. I'm going to have to find that side. They have given me the slant height and they've given me the height. And one of the things you need to see here is that when they've given you those two, there's a length in here and that makes a right triangle. That length that I've made blue is the apothem. So if we were to draw this hexagon, the base of that figure, the apothem would go right there. And we need that for the area of the base. So as we look at that, this is a right triangle and it has 10 for the hypotenuse, 8 for the height. Pythagorean theorem would give me the answer, but I also recognize that as a Pythagorean triple. It would tell me that this is 6. Now, remember in a hexagon, when we make that figure, we have a 30, 60, 90 triangle. So that would be the long leg. When I go from the long leg to the short leg, I have to divide by radical 3. When I divide by radical 3, that would be 6 divided by radical 3. That is equal to 2 radical 3. When I simplify, multiply top and bottom by radical 3, that's what I end up with. Which tells me that this, or what it tells me is that a full length of this would be 4 radical 3. So for the perimeter of the base, 6 times that. So 1/2 times 6 times 4 radical 3, all times the slant height, which is 10. That would give me the lateral area. So that would be 120 radical 3. And at this point, we're just going to leave it as a whole number. And that would give me the area of all of the triangles around that pyramid. That's what that formula does for me. And so that gives me the lateral area. Now we need to add the area of the hexagon. Well, since we already have the apothem, and since we now have a side, the 1/2 the apothem is probably the best formula to use. So 1/2 of 6 times, and then again we have 6 times 4 radical 3 for the perimeter. So we will be adding, let's see, 3, 12, 72 radical 3. And so my answer ends up being 192 radical 3. That would be more than acceptable as an answer. That would be an exact answer as a review. And then on the calculator, if we needed that actual round to the nearest 10th, we would put that in like so, and we would get 332.6. So that would be how you find the surface area of a pyramid. Now that gives you 3 good examples of that with different figures. The hexagon is certainly easier than the pentagon, but you can look at the pentagon for any of the other shapes that you might do. Okay, so now we go to a cone. Okay, and again, I'm going to still use that same formula up there. 1/2 perimeter of the base times the slant height plus 1 base area. In this picture, they've given us the radius of the bottom and then the slant height. So this is going to be fairly easy. Remember, the perimeter of the base is 2 pi r, or pi times the diameter. So when we put that in here, 1/2 gets rid of the 2 pi r. So it's just pi r. And so in this case, you're going to end up, I'm going to write it out for you, 2 pi and then 5, and then the slant height is 12. Plus, you're going to add the base area, but I'm going to, first of all, calculate the slant height. It's going to end up being 60 pi, not the slant height, the lateral area, sorry about that. And so that's the surface area around the cone, okay? If we were to cut this and be able to fold it out, they show you a picture of that in the book. I would encourage you to look at that. It's how they make the cone. And so this would be the lateral area. Now I need to add the base area. That's just simply pi r squared. So that would be pi 5 squared, 25 pi. And so exactly the total surface area is 85 pi. So my two answers, again, 60 pi, 188.4, or 188.5 for that, and then 85 pi, and I get 267. And so there are my answers for my cone. So you see that. Now, again, remember, if that 12 had not been on the slant height, let's say it was the height, now I'd have to calculate that. Well, what kind of triangle do we have here? We have a right triangle, 5, 12, and so the slant height would be 13. So it would change our area a little bit, but just remember that in a cone and in other pyramids, you're going to need to use Pythagorean theorem sometimes to find the slant height or the height, depending on what you need. And so I think that's all of the examples. There's one other thing from the book that I wanted to show you. So this number 4 here, they talk about a conical tent is shown at right, round answers to the nearest tenth. I'm not going to find the answers for this, but find the lateral area of the tent, describe what it represents. Well, that's the walls of the tent. That would be what the lateral area is. So if you can think of a tent, that would be the walls, or this might be a teepee. Now, and then it says find the surface area of the tent, describe what that represents. Well, that's the walls of the tent and then the floor. Now, if it's a teepee, most of the time there's not a floor other than dirt. And then, but in tents, usually tents do have a bottom to it. And so when you have the surface area, it includes the base of the tent or the bottom of the tent. So just keep that in mind. Hopefully, all of that helpful information and examples will help you get through the assignments on Wednesday and Thursday. Hope all is well, and have a great day.